Quadratic equations in one variable. An equation can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal 0, so it's called a quadratic equation. And this form, ax squared plus bx plus c equals 0, is standard form. A quadratic equation is a second-degree equation. This is an equation with a squared variable term and no terms of higher degree. So, second, second, second. One way to solve quadratic equations is by factoring. If m times p equals 0, what do we know about m or p? Well, we know that either m equals 0 or p equals 0 or both. Because that's the only way we can get 0 as an answer, if one of the factors is 0. So if a and b are complex numbers with ab equals 0, then either a equals 0 or b equals 0 or both. Now the rules for factoring polynomials. First, always look for a greatest common factor and factor that out. Then if you have two terms, if it's a difference of squares, such as a squared minus b squared equals 0, it can be factored, and that factors into a plus b times a minus b. If it is a sum of cubes, a cubed plus b cubed, then it can be factored a plus b times a squared minus ab plus b squared. If it's a difference of cubes, a cubed minus b cubed, that factors into a minus b times a squared plus ab plus b squared. Notice that these two term forms are very similar, a plus b and then an a squared, an ab, and a b squared term. And the only difference is these signs and these signs. Well, it helps remember that the first one, the binomial, the a and b, plus is the same if this is a sum, this is plus. If this is a difference of squares, the subtract is here. Perfect squares factor, which we have a squared plus 2ab plus b squared. That factors into a plus b, the quantity squared, or you can write it a plus b, which of course means a plus b times a plus b. And a general quadratic equation, ax squared plus bx plus c, can be solved in a variety of ways. For factoring, the best way to do that is guess and check using FOIL. Here's an equation to solve by factoring. First thing we have to do is get it in standard form. 10x squared plus x minus 2 equals 0. And I always try by factoring first. We are supposed to solve this by factoring. So to get 10x squared, I'm going to say 5x and 2x. The fact that this is negative tells me one of these signs is positive, one is negative. And to get 2, the only way to get 2 is 1 and 2. And I'm going to put the 2 here and the 1 here. Partly because if I put the 2 here, 2 would be a factor of this binomial and should have been a factor of the whole trinomial. Now, this is 4x and 5x. I want the positive x, so 5x, the positive, needs to be bigger. Now I set each of these little terms, these two binomials equal to 0. I find 5x equals 2, x equals 2/5, and 2x plus 1 equals 0. So 2x is negative 1, and x is negative 1/2. Let's try another one of these. Ooh, very first thing for factoring is the greatest common factor, and I see that x is a common factor here. So x times 4x minus 1 equals 0. So my two factors are x and 4x minus 1. So either x equals 0 or 4x minus 1 equals 0. 4x will equal 1 and x is 1/4. Another to solve by factoring. Get it in standard form. First, 3x squared minus 11x minus 4 equals 0. The only way to get a 3x squared is a 3x and x equals 0. Signs are different. It's pretty big. Instead of 2 and 2 here, I believe I'm going to use the 4 and 1. So give me 3x and 12x. A negative 12x will make it a negative 11. So 3x plus 1 equals 0. 3x equals negative 1. And x is negative 1/3. X minus 4 equals 0. And x equals 4. Another way to solve quadratic equations is by using the square root property. We know that if x squared equals k, then x equals the square root of k, or it equals negative the square root of k. Solving these quadratic equations. X squared, x then, basically I'm going to take the square root of both sides. So x equals plus or minus the square root of 29. Since 29 is a prime number, we are done, and this cannot be simplified any farther. Here, x squared equals negative 144. So we'll take the square root of both sides, and x equals plus or minus the square root of negative 144. Well, two things. This is a negative, so we know that x is going to equal plus or minus I times the square root of 144. But we also know the square root of 144 is 12. So x equals plus or minus 12i. This one looks a little different, but since we have a value on the right-hand side that has an x term in it and it's squared, we're just going to take the square root of both sides. And x minus 8 here will equal plus or minus the square root of 24. Now 24 happens to be 4 times 6. So x equals, moving the 8 to the other side, 8 plus or minus 2 times the square root of 6 would be our simplified answer. And we do always want our answer in lowest terms and simplified form.